Hi, everybody. We're going to take a look at 2.1 today. So lesson 2.1 is all about parallel lines. There's some properties when you're dealing with parallel lines that kind of tell you some information. You can see this example up above. They're kind of referencing each of these angles in between all three of these lines. And there's certain relationships that are happening between some of these angles that you can determine values for. So for example, angle 2 and angle 3, if you add those up, you can see that they form a straight line. And we all know straight lines have 180 degrees. So I know that if I add those two angles up, they should add up to 180. Another type of relationship, and we'll look through all these in just a second, is something like angle 6 and angle 7. Those are angles that are equivalent to each other. They're congruent to each other. So let's start going through this and kind of looking at what this lesson has to offer. So example 1, identify angle pairs. So identify the pairs of angles of each angle type made by the snowmobile tracks. So what you're going to see typically in these types of questions is you're going to see, and I'm going to go back up and reference the one at the top. You're going to see a pair of sometimes parallel lines. And the way I know that they're parallel is because of these little red arrows right there. Those little one single red arrows on each of those lines indicate that those two lines together are parallel to each other. And parallel lines never cross. So it doesn't matter if you drew this line to the left and to the right forever. Same thing with this line. They would never get any closer or any farther apart than what they are right now. So those are my parallel lines. And then this is what they're calling a transversal. So this line that's just kind of almost seemingly randomly drawn across those two parallel lines, it's called a transversal. That's the vocab word for it. And when that happens, when we have a pair of lines and then we have a transversal, there are relationships that start to form. So that's what they're doing with example 1. It's just kind of a real world scenario. Sometimes these real world scenarios kind of take a little bit of imagination. But they're having snow in the background, and then you can see that this line here and this line underneath that little word bubble are parallel lines to each other. So that's what it's trying to indicate. And then this line right here that the skier is on, that's my transversal. Okay. So you could see it starts pairing up these angles, angle 4 and angle 8. So 4 is right here, 8 is right there. 1 and 5, right there and there. 2 and 6, there and there. And 3 and 7, those are what they call corresponding angles. So basically, they're always going to be equivalent to each other. If I have a set of parallel lines and a transversal, the relationship between corresponding angles is that they'll always be equivalent to each other. So if I say angle 3 is, 120 degrees, well, angle 7 has to be 120 degrees. Okay. They're also saying angle 2 and 8. So where's that at? Down here on the bottom left, up here at the top right. And then 5 and 3. There's 3 and there's 5. They're calling those alternate exterior angles. So let's piece together where they're getting these two words, alternate exterior. Because when I first started learning this, I was like, man, how do I know that that's the exterior? Because isn't this on the outside of those 4 things too? So let me piece it together for you. Alternate literally means one side and then the other. So let's talk about angles 2 and 8. So angle 2 is on the left side of that transversal, and then angle 8 is on the right side of the transversal. So when they say alternate, that's what they're talking about. They're saying it's alternating sides of the transversal. Okay. And then exterior, now they're talking about the parallel lines. So if I'm talking about alternate sides, I'm talking about alternate sides of the transversal. When I start saying exterior angles, I'm talking about outside of these parallel lines. Okay, so ignore all the stuff between them. We're not talking about that's inside, that's interior, right? In between the parallel lines. Exterior angles talk about the outside, the exterior of the parallel lines. So that's super important to know. 7 and 1, 6 and 4. So here's 7, there's 1, there's 6, there's 4. Now this is very similar to alternate exterior angles, but they're calling it alternate interior, right? Take a look at 7 and 1. I wish my pencil wasn't so wide, but if you imagine that transversal there, notice that it's still alternate because one's on the right side, one's on the left side. So they're alternating sides of that transversal. But now they're talking about interior angles. So now we're concerned about the inside of the parallel lines. Okay? So alternate refers to the transversal. Interior or exterior talks about the parallel lines. They start talking about postulate, which is basically like a rule for same side interior angles. So this is telling you some information that if you have two angles on the same side, so unlike the problem we just looked at, that's alternating sides, this is the same side. So you could see 1 and 2 are both on the right side of that transversal, and the interior. So see that 1 and 2 are also inside those two parallel lines. So when that happens, the angles are supplementary. So there's 2 vocab words if you didn't catch them already. One is supplementary, one's complementary. Okay, so supplementary angles will add up to 180 degrees. You could see it, reference it right here. So if you add up angle 1 and angle 2, and if you don't know, that's the measure of angle 1 plus the measure of angle 2. That'll add up to 180 degrees. Okay, we don't know what the actual measurements are. We just know that the 2 angles add up to 180 degrees. And then if you have something that's complementary, that adds up to 90 degrees. So keep that in your brain bank. Complementary is 90 degrees, supplementary is 180. Example 2. Explore angle relationships. So for me, I kind of like these types of problems because it's a ton of information, but you're only pulling little pieces of information out of it, right? So how can you express each of the numbered angles in terms of x? Like I said at the beginning, you have 2 parallel lines. How do I know they're parallel? Well, because of these little arrows that they have on top of those lines, right? Any other line in this problem, if it had one of those little indicators right there on it, then that would identify that those 2 lines are parallel to each other. And then this is my transversal. So when you have a situation like that where you have a pair of parallel lines and a transversal, there's relationships between all this garbage that's happening on the inside there, okay? Angle 7 and the angle with the measure of x are vertical angles. So this is what they call a vertical angle. They're opposites of each other at that x. So angle x and angle 7 are vertical, which means that they're equivalent. They're equal. They're congruent. They're the same. So if I say angle x is 20 degrees, it's not, but if it is, then I know that angle 7 is 20 degrees. Okay. Both 6 and 8 each form a linear pair with the angle that measure x and therefore are supplementary to it. We just talked about supplementary, so know what that is. So 6 and 8, if I look at angle x and angle 6, you'll notice, and again, I'm going to draw my book, but don't do it on your end. If I add up those 2 angles, notice they form a straight line, right? If I add x and I add angle 6, they add up to a straight line. And we know a straight line's 180 degrees. Same thing with x and 8. If I go top to bottom, right? They add up to 180 degrees. They form a straight line when I add those 2 angles together. So both of those are supplementary. By postulate 2.1, that's the one that you covered at the top. That's talking about same side interior angles. You know that angle 2 and angle x are supplementary. So here's that, angle 2 and angle x. Those are both on the same side, right? The same side of the transversal, and they're both on the inside of the 2 parallel lines. So angle 2 and angle x form the same side interior angles. And you know that they add up to 180 degrees. They form a straight line. From that, you can make conclusions about angle 1, 3, and 4, like you did with 6, 7, and 8. So let's talk about that real quick. You know that 2 and x add up to 180. So just like we talked about before, angle 2 and angle 4, those are vertical angles. So you know they're equivalent to each other. They're the same. And then again, you know that angle 1 and 2, when you add those together, they form that straight line. And then same thing with 2 and 3. If you add up those angles together, they form a straight line. So when it forms a straight line, you know those angles are supplementary. They add up to 180 degrees. All angles equal to x are angle 1, 3, and 7. So angle 1, angle 3, and angle 7. Let me explain why. So angle 7 is equal to x because they're vertical angles. And then angle 1 and angle x are corresponding angles. So they're the same. They're always equal to each other. And then because angle 1 is the same as angle x and they're corresponding to each other, angle 1 and angle 3 are vertical angles. So again, angle 1 and angle 3 are equal to each other. Always. That's the rule. They'll always be equal to each other. The angles that are supplementary to the angle with measure x have the measure 180 minus x. These are 2, 4, 6, and 8. And we already talked about that. So angle 2 and angle x, those things will add up to 180 degrees. So if I start off with 180 and I subtract x, it'll give me angle 2. Okay. Then you can try it. Take a look at another theorem at the bottom. If a transversal intersects two parallel lines, then alternate interior angles are congruent. So same kind of idea, two parallel lines. There's my transversal. Angle 1 and angle 2, those are both alternate interior angles. So notice that they're on alternate sides of the transversal. One's on the left. Well, I was going to say one's on the left, one's on the right, but we'll say angle 1 is on the right, angle 2 is on the left. So they're on opposite sides of the transversal, and they're both in between the parallel lines. So alternate, because they alternate, interior angles. So very similar to what's happening here. They're just kind of talking about more relationships. Corresponding angles theorem. So again, two parallel lines, a transversal. These are those corresponding angles that we were talking about a second ago, that angle 1 and angle 2 correspond to each other. So literally, if I cut that transversal right there and I move that bottom piece on top of the top piece, right? Like if I cut that off and I moved this up here, all those angles would map to each other. Angle 1 would lay right on top of angle 2. Those things would be equivalent to each other. So corresponding angles theorem is basically just saying if you have two parallel lines and a transversal, angle 1 is going to match angle 2. And it's true also, I mean, you could talk about any of these angles. This angle right here would match this angle right here. This angle right here would match this angle right there, right? And of course, this last one, I don't know, what didn't I use yet? A box. And this one. So all of those map to each other. All of those are equivalent to each other. I'm going to get in big trouble drawing all through my book like this. All right. And then the next one, alternate exterior angles. So by now, you're probably getting used to what they're talking about when they say alternate or same side, and then exterior versus interior, right? Alternate, that's talking about on alternating sides of that transversal. Same side is talking about on the same side of the transversal. So either on the left or on the right. Exterior, that's talking about on the outside of the parallel lines. Interior would be talking about on the inside of the parallel lines. So same kind of idea here. If you have a set of parallel lines with a transversal, these alternate exterior angles are also equivalent to each other. So angle 1 and angle 2 are equal. They're congruent. Same thing with this angle right here. That would be congruent to that. And like we talked about up above, this is congruent to this, right? This is congruent to this. There's a lot of relationships happening here. But each one of these theorems is kind of breaking those down and showing you what all those relationships are. All right. Example 3. Prove the alternate interior angles theorem. So basically, this is just a proof. It's just a way to say, hey, if I give you this information, tell me why, or show me the steps that tell me that angle 1 is congruent. That's what that sign means, congruent to angle 2. So these things always start off with a given. This given is saying that M is parallel. That's what that sign means, to N. So I know that these two lines are parallel. Also, based off the picture, I know they're parallel because of those little red arrows. That signifies that they're parallel to each other. And what they want you to prove with these steps down here is that angle 1 is congruent to angle 2. So they walk you through a plan. Obviously, they showed you some theorems up until this point right now, and that's what they're going to adopt is that same side interior angles postulate. So they're going to connect these two angles first, 1 and 3, and just kind of talk about their relationships, and then they'll move on from there. So the same side interior angles postulate says that angle 1 and angle 3 are supplementary. If you forgot it, I think it's back on page 72, the previous page. So because these two angles are supplementary, they add up to 180 degrees. Okay. So down here, they call these two-column proofs, basically because they have two columns. One column is the statement. One column is the justification or the reasoning. Okay. So walking through their proof, they're saying that line M is parallel to line N. And you don't need any other proof other than it's given, because they're telling you that at the start. And they're also showing you that in the picture. Then they start saying angle 1 and angle 3 are supplementary based off of that postulate we talked about on the previous page. And here's the reason why you can say they're supplementary. Why do they add up to 180 degrees? Because of the same side interior angles postulate. Or if you just wanted to write postulate to 1, I mean, that's another name for it in this book. But usually if I was writing this out for my reasons, I would just write same side interior. I wouldn't write angles postulate. That's just kind of extra. So when you say same side interior, I know exactly what you're talking about. Because of that, because we proved or because we stated that angles 1 and 3 are supplementary, now we can show that. The measure of angle 1 plus the measure of angle 3 equals 180 degrees. How do we know that? Because that's the definition of supplementary. Supplementary is a vocab word. The definition is that the two angles add up to 180 degrees. The next thing you can see, though, is after they prove that, they're showing you that angle 2 and angle 3 are also supplementary. They form a straight line. So you know that those also add up to 180 degrees. So that's what we state. Measure of angle 2 plus the measure of angle 3 is 180 degrees. And then you know that because of the angle addition postulate. If you add up those two angles, they add up to 180 degrees. And then they're saying that because of statement 5, the measure of angle 1 plus the measure of angle 3. So if you add up these two, let me erase my pencil. If you add up those same side interior angles, they're going to equal, right? Because those are 180. They're going to equal the measure of angle 2 and the measure of angle 3. Because these two angles together add up to 180, and these two angles together add up to 180. They're both equivalent. Now that I know that, the measure of angle 1 has to equal the measure of angle 2. Well, look back above it in the previous step. If both sides of this equation has the same measurement, I could just subtract the measure of angle 3 from both sides. And look what I'm left with. If I take the measure of angle 3 out of the left and I take the measure of angle 3 out of the right, I'm left with the measure of angle 1 equals the measure of angle 2. Which, if you look back, that's what you're trying to prove. So that's what this is talking about. It's asking you to walk them through steps that end up proving a certain rule of parallel lines and transversals is true. So that's example 3. Okay. Example 4. Use parallel lines to prove an angle relationship. So it looks like there's a lot of stuff happening right here, but don't get super overwhelmed with all the junk that's on the page, because more than likely you're only going to use a piece of all that junk, and some other stuff is almost just like a distraction. So let's see what they're trying to do here. Use the diagram to prove the angle relationship. Given line AC is parallel to line DF, so this line is parallel to this line. Line BE is perpendicular. That's what that means. Perpendicular to line DF. So BE, that's this one right here, is perpendicular to DF. You can also tell that that's true because they got a little right angle there. So you know that that line is perpendicular. It's coming straight off of DF. And then they're also giving you that the angle AEB. So let's take a look at that. AEB. So that's talking about this angle right here. Is congruent to angle CEB. So CEB. So that's talking about this angle right here. Again, if they didn't give that to you right here, you could just look over here and tell that information. I'm going to point out all 3 things. Here's the parallel lines. How do I know they're parallel? Well, because they have that little red arrow on top of them both. So that's indicating that they're both parallel. How do I know that BE is perpendicular to DF? Well, because BE forms that right angle off of DF. So that means that they're perpendicular to each other. And then how do I know that AEB is congruent? It's the same as CEB. Well, these little red tick marks that are right here, I drew over the top of them, but let me erase that. So that red tick mark and this red tick mark, that indicates that both of those angles are equivalent to each other. So it's just a visual way to prove that, you know, the given is right there. So what they want you to prove is that angle BAE, so BAE, that's talking about this angle right here, is congruent to BCE. So BCE. So they're talking about this angle right here. Hold on, I gotta go let my dog out because she's gonna pee.